Hello everyone, welcome to Diksha Karnataka YouTube channel. I hope everyone is doing well, and today is the time for me. So many of you are asking that, sir, please restart Sankalp, please restart Sankalp as it was there in the past. So we were doing some PYQs. So now we have decided that we will go back to our old ways of classes here, and it will be additional than what we were doing in the Sankalp series. So we will be not only doing PYQs, but also we will be discussing theory. So today I have decided just let me go to the correct stream. Yes, right. So now time for me to discuss not only the theories but also the previous year questions. So today's session will include the theory coverage of the chapter current electricity, as well as we will be discussing PYQs. Now before I start, I just wanted to tell you what are all the concepts from this chapter. So the electric current, basically the first part of the chapter is electric current. Here we have Ohm's law, limitations of Ohm's law, resistance and resistivity, combination of resistance, grid velocity, conductivity, mobility. Also we have electrical energy, and we have cells in series, cells in parallel. Now there is also Kirchhoff's laws and Wheatstone bridge. These portions I will be covering on Saturday. There will be a special live on Saturday. There I will be discussing about circuit theory. That will include Kirchhoff's laws, how to apply circuit theory. That is not only for KCET, that will cover your PU board requirement as well. So we will be solving a lot of questions on Saturday for KCET, for your PU board exams. Also we will be dealing Kirchhoff's laws, Wheatstone bridge, how to solve questions where Wheatstone bridge is unbalanced Wheatstone bridge, right? So if you have any other doubt, please let me know in the comment below, sir, I want this. So for that I will be covering entire circuit theory. I promised you in one of my previous live sessions that I will be covering KCL, KVL. So that will be covered on Saturday's live, where I will be discussing about KCL, KVL, problem solving skills on how to solve KCL and KVL related problems, step by step guide of that thing. So many of you are struggling with circuit theory related questions. So if you attend that session, it will be very helpful for everyone. So now let me start with the first topic of the day, electric current. So what is the electric current? And by the way, this is the most important chapter of your KCET. From this chapter you can expect up to 6 questions. Maximum 7 questions also came in one of the previous years. So this is the most important chapter of your KCET. Okay, this chapter and also the next chapter, moving charges and magnetism, there also 5 questions on an average comes from the moving charges and magnetism chapter. So these 2 chapters are the most important. These 2 chapters I will be covering the first this, next will be KCL, KVL on Saturday, and next week class will be moving charges and magnetism. So even if you have missed some of the classes in the past, worry not. Most important chapters are going to be covered first, then we will move on to the remaining chapters. The net amount of charge small q is flowing across the area of the forward direction of the time interval t, then the current is. Suppose we have a conductor. Okay, we have a conductor through which some current is being flown. Now we denote the current by I. Now what is current? Current is basically flow of charges, right? So if say q amount of charge flows through the conductor in some time t, the total charge that is flowing through the conductor is q, and it is after some time t, then the current is in simple words is given by q by t. Unit of current is ampere, and it's a fundamental quantity, so dimension of current is A. Okay, so unit is ampere and dimension is denoted by A. It's a fundamental quantity, one of the 7 most fundamental quantities. Currents are not always steady. So current in a circuit is not steady. So if you are staying in homes, you might be using some voltage stabilizers, right? Voltage stabilizers, what they do, they would regulate the current that is being flowing into the circuit. Okay, so current is not always steady, current is fluctuating. Now, so how then we can define current? So this Q is not fixed for a given amount of time. So for that we have to use the differential form of current, which is given by limit delta t tends to 0 delta q by delta t, and as per the definition of differentiation, this is the differentiation. So charge dq by dt is basically the current in a circuit. Now this sometimes q will be given in terms of some variables of time. You have to differentiate it to find the current. This type of questions are common. Not KCET exam it did not came, but in JEE exam it came. Maybe this year they will give you a question based on this formula. Okay. Now electric current in conductors. So what do we need for electric current? We need something called conductors. Okay, conductors are those through which electric current can pass. Now electric charges experiences a force in the presence of external electric field. We already studied that in our electrostatic statics chapter, first chapter, electric charges and field. So there we know that if there is an electric field present, if we have a charge, positive charge, then this charge experiences a force in the direction of electric field. If the charge is negative, okay, negative charge, it experiences a force in the opposite direction of the electric field. Okay, electrons are negatively charged. Okay, electrons in a conductor, what is the speciality about conductors? Conductors have a lot of free electrons. So electrons being negatively charged move opposite to the direction of the electric field. So electrons are negatively charged, so they will tend to move in the direction opposite to that of the electric current, electric field. So metals having a large number of free electrons, these electrons accelerate in the presence of external electric field, and that gives rise to the electric current. So when I say current is basically flow of electrons. Okay, but there you have to remember one important thing. I hope you already know that. So suppose we have a conductor, the current is flowing in this direction, then electrons are flowing in the opposite direction. Okay, conventionally when the initial concept of current came into the existence, okay, we were not aware of the presence of electrons. Okay, so even without knowing about electrons, we discovered current. We were using current in our life also, but electrons were not yet discovered. So how the scientists that time when they discovered current, they said positive charges are moving in this direction. But later on it was realized that positive charges are not moving, actually electrons are moving, and electrons are moving in the opposite direction that we assumed. And this is called conventional current. Conventional current means the convention that was used in the past. Pranavi sir, I would have been better if you had focused more on problem solving and just brushing up the concept very briefly before solving it. Mudit Mishra is saying, sir, koi pad nahi raha ko kyun pada rahe. Sarath is saying, I covered 70% of the boards and I am failing in MCQ and KCET MCQ. What is the method of improve this? Pranav is saying, read NCERT. So we will be solving a lot of MCQs today's session as well. Don't worry about it. We will be solving a lot of questions, and I will request Sharath to stay with me through the session so that you can understand how to approach a difficult concept. Okay, so it will be some students were asking about old ways of Sankalp. So we have mixed both good things. Okay, we are discussing some concepts, we will be discussing about some theory, but we will also solve a lot of questions as well. Don't worry about it, questions are coming. Just hold for few minutes. So Ohm's law and resistance. So Ohm's law is, obviously we know that if temperature and other physical options remain same, then the current through a conductor directly proportional to the voltage difference, and V is proportional to I, so V is equal to IR. R is called resistance. Now what is the resistance? Resistance is the opposite force which is applied by the current. So And someone was saying, sir, no one is studying. Yes, everyone is studying, Mudit. If you are not interested, I cannot help you, but if you are interested, I can help you. So that is the basically your mutual understanding, mutual interest, right? And I love to teach, so that's why I'm teaching. So current is basically going in this direction, electrons are moving in the opposite direction. Now electrons being negatively charged, they are continuously being repelled by other electrons and also being attracted by the nucleus. So that's why the electron is not moving steadily. They are getting obstructed by the other atoms. So that's why there is a term called resistance. Now resistance is given by rho L by A. Okay, rho is called resistivity of the conductor and it depends on temperature. Okay, resistivity depends on temperature. Now one more thing, there are few things that you have to remember about resistivity. So if you plot resistivity versus temperature graph, then for conductors, for metals or any other conductor, the resistivity decreases. Okay, this is conductor. Okay, so these are conductors for which the resistivity decreases steadily. For some material, the for conductor resistivity not decreases, my mistake. For conductors resistivity increases. For conductors resistivity increases with temperature. So if you are increasing the temperature, then resistivity increases. This is conductors. This graph is very, very important. Based on this question came in 2025. There are few materials for which resistivity decreases. Now resistivity increases means it becomes a bad conductor. But there are some materials for which if you increase the temperature, the resistivity decreases. That means it becomes a good conductor. Lower the resistivity, conductivity is good. These are called semiconductors or semiconductors. Semiconductors, we will study about them in a complete chapter later on, but for now you just know that they are called semiconductor. There are few materials for which the conductivity neither increases nor decreases, it almost remains constant. Okay, example for them are nichrome, manganese, okay, there are examples of conductors whose resistivity almost remains constant. If you increase the scale, if you get a flat line. Okay, so these conductors are used in standard resistor because their resistance remains almost constant. So whatever resistance box that you are using in your laboratory for your practical practices, those are basically made of nichrome or manganese. Okay, so based on this graph, there was one question in 2025. Now let's look into a question. A wire of resistance 3 ohm is stretched twice of its original length. The resistance of the new wire will be. This is taken from our KCET PU2 book from the page number 119, question number 64. If you are interested to purchase this book, you can scan this QR code and you can get the book. So wire of resistance 3 ohm is stretched twice of its original length. The resistance of the wire will be. So what we have done, we had a wire of length say L. Okay, now what we have done, we have stretched the same wire to twice of its length. So when you stretch the wire twice of its length not only increases, its area also decreases. So initially suppose the area was A, the new area will be A by 2. Okay, and there is a formula for that. So if you increase the length by n times, it can be double, it can be triple, it can be halved, it can be 1/3, does not matter. When you change the length to NL, as long as you are either stretching it or compressing it, okay, without adding any extra material. So that is very, very important. You are not adding any extra material to it. So if you change the length by NL, the area will be changed to A by N. and the new resistance will be N square R. The new resistance will be N square R. So what is the value of N? For this given problem, resistance, you are stretching the length twice, so it will be R dash will be equals to 2 square into the old resistance, which is given by 3. So 4 into 3, that is equals to 12 ohm. Okay, so 12 ohm is the correct answer. Hi Austin, hi Ashel, Sazia, hi. Sir, only KCET read NCERT book. If you can read NCERT book, very good. NCERT has a lot of things, but not everything do come in KCET. But in KCET, everything comes from NCERT. Okay, so you can if you are studying mathematics, you are know about superset and subset. So KCET is a subset of NCERT. NCERT is a superset. In NCERT there are a lot of concepts. Not everything is important in KCET. That's why we are only doing some important concept, and whatever we are doing in our lecture, they are all taken from NCERT itself. Okay, not as anything is outside NCERT. And if you want to know more about KCET exam, KCET details, when the date is announced, when your PU board, and more details about blueprint, then definitely you have to join our WhatsApp channel. The link of the WhatsApp channel is given in the description of this video. Also, all materials of this lecture and future Brahmastra lectures as well will be shared on our WhatsApp channel. So don't go anywhere, join the WhatsApp channel so that we can give you more heads on what is going to come in future. Okay, so I request everyone is go to our WhatsApp channel if you have not yet visited. Also, subscription is important for us. We are very close to 1 lakh subscribers, so I request you to subscribe to our channel if you have not yet subscribed, and there will be a surprise coming towards you if when we hit 1 lakh subscriber. Don't go anywhere. Okay, now drift velocity, mobility, and few other terms. Formulas are important. What is drift velocity? Drift velocity is given by Vd equals to charge of an electron, electric field divided by m into tau. Now this formula is not that important, but this formula I, current, in terms of this velocity is very, very important. Current equals to NEA Vd. This formula you have to remember by heart. Okay, NEA Vd. NEA Vd means current is given by number density of electrons, charge of an electron, area of the conductor, and Vd is the drift velocity. Now for a given conductor, the quantity A into Vd is constant. That means if current is constant, if current is steady means constant current. Okay, if current is steady, then A into Vd should be constant. Okay, suppose we have one area like this, one area like this. Suppose the area of this is A1, well, drift velocity is V1. For this area is A2, drift velocity is V2, then A1 V1 should be equals to A2 V2. It is like the continuity equation that you have studied in your PU1. Current density is current per unit area, I by A, which is given by NE Vd, also NE square ET tau. This formula is not important, you have to remember this one. Okay, next is mobility. Mobility is drift velocity per unit electric field. So this first equation is important, and we have seen one question came from this formula as well, T tau divided by m, and conductivity is given by 1 by rho. Conductivity is in reciprocal of resistivity, and it is given by J by E NE square tau by m. Okay, so conductivity and resistivity are step brothers. Okay, one is reciprocal of the other. Now Ohm's law in terms of current density, that is also an important thing. So Ohm's law is given by I into R, and I can be written as R can be written as I rho L by A. R is, what was the value of R? R was rho L upon A. Okay, R is equals to rho L upon A. So now if you consider I upon A, I upon, what is the value of I upon A? I upon A is the current density J. So V equals to J rho L. V equals to J rho L. Now we know that E actually is given by, magnitude of E is given by dV by dl when potential is changing. Now for current, V itself represents the change in potential. So this dV itself becomes V, and L is the distance, so dl becomes L. So electric field will be given by E V by L. It is a magnitude. Obviously there is a negative sign that we are not considering. So V equals to E into L. Now if you put that value over here, L cancels and you get E equals to J rho. Now based on this formula also one question came in your KCET. Okay, so they asked E is equal to what is the value of this constant. This constant is nothing but rho. Okay, but in actual form J has to be equals to E by rho, and it is given by J equals to sigma E, and it is also given in vector form as well. Okay, current itself is not a vector quantity, but current density is a vector quantity. Very interesting part. Why current is not a vector quantity? If you know the answer, answer me in the comment section of this video. So what is saying? Ashel D'Souza sir, how to read NCERT sir? Manjunath is saying hi Manjunath, welcome back. How to read NCERT? I have made one old video of how to read NCERT. I will try to make one more new video on how to read NCERT, what are all the important portions in NCERT. I will share that in future. What first of all you have to understand, you have to go through the PYQs of your KCET, and then realize what are all the important concept that is coming again and again in KCET. So there are few fixed concepts. Okay, for example, in this chapter you will see a lot of questions coming from resistances, lot of questions coming from drift velocity. So you have to understand those and any detailed line regarding that concept. Okay, so how drift velocity is changing with temperature, how drift velocity is changing with resistance. Okay, so these things if you understand, it is mentioned in that NCERT part itself. So once you read that, you will know that okay, these are the important concept, these are the important things. You underline that, you highlight that using a highlighter. Okay, that's how you should read NCERT. When you are opening the NCERT, you know that only the highlighted portions you need to revise. Remaining portions you can skip. There are a lot of extra things in NCERT which are not directly coming in KCET. So the understanding the important concept which are important is very important, and then you have to do the NCERT, and if possible solve the exemplar questions as well. Exemplar questions are MCQ. There are some MCQs, some numerical questions, and that's how you can read NCERT. Okay, here sigma is called conductivity of the conductor, and it is exactly opposite to that of the quantity rho. Limitations of Ohm's law. Ohm's law are not always, Ohm's law is not always valid. So these are all again taken from NCERT, but why I am teaching you this? Because in the exam there will be a question, which of the following cases Ohm's law is not valid? So you have to identify the cause. That means it is actually asking you limitations of Ohm's law. Okay, so they will give you 4 options. One of the options should be from these limitations. Okay, so that's why you have to understand what type of questions might come from NCERT textbook. Okay, so they will, in the textbook it is given limitations of Ohm's law, but in the exam they will ask in which of the following cases Ohm's law is not valid. Okay, so you have to identify the correct statement. Correct, right? So V ceases to be proportional to I. So generally V versus I graph is a straight line graph passing through the origin. But in some cases, as you going away, if you are going higher voltage range, okay, at higher voltage range, the graph slowly curved away. That means it is no longer a straight line graph. That means Ohm's law is no longer valid. It was valid up to some point over here, but slowly then it is deviating from the standard line. That means Ohm's law is no longer valid. Next is the relationship between V and I depends on the sign of the V. That means as you are increasing the voltage, you are getting a graph like this, and if you are decreasing the voltage, negative voltage, you are getting a complete different graph. Okay, ideally if you draw a graph for a cell. If you are increasing the voltage, you should get a graph like this. If you are decreasing the voltage, you get a graph like this. So the straight line will continue without any break. But if you get, suppose you are getting a graph like this in the forward in the positive voltage, and you are getting a graph say like this in the negative voltage, that means Ohm's law is not valid. Okay, so in this case positive and negative, the sign of current depends on the sign of the voltage. That means voltage and current is having different behavior in different direction, then Ohm's law is not valid. Next, the relationship between V and I is not unique, that is there is more than one value of V for the same current. So for example, let us take this graph. Now if I give you only up to this point, you will say okay, almost it's Ohm's law. There is some deviation around here, so maybe the first point is true. But up to this point Ohm's law is exactly valid. But after this point, what is happening is that Ohm's law is no longer valid. Why so? Because for different voltages, you see that for different voltages V1 and V2, you are getting same current. So current is same for different voltages, which is not allowed in Ohm's law. Ohm's law says that for each unique value of voltage, you should have a unique current. Okay, this straight line graph. So for unique value of voltage, if you plot V versus I, for unique value of voltage, you should get unique value of current. So that is not happening over here. That means Ohm's law is no longer valid over here. Now combination of resistance, important concept. I know most of you already know that series combination is R1 plus R2 plus R3. Parallel combination is R equivalent is 1 by R1 plus 1 by R2 plus 1 by R3. But few things I want to tell you. If n number of resistance having equal resistance R are connected in series, then R equivalent becomes N into R. And if n number of equal resistances are connected in parallel, then it becomes R upon N. Okay, this is this, this is this. So n number of resistances having each of them have the same resistance, then the equivalent resistance becomes R upon N for parallel, and for series N into R. And if only two resistances are there, then R equivalent is given by R1 R2 divided by R1 plus R2. Right, now here you have to remember that if you are using this formula, at the end your target is to find R equivalent, not 1 upon R equivalent. I have seen students after solving everything, they keep the answer as it is because they forget to take the reciprocal of the answer. So you at the end you have to take the reciprocal. Okay, now let's move into the electrical energy and power. So energy is given by VIT, vitamin, and power is given by Vodafone Idea, V into I. Okay, now we will solve one question. If voltage across a bulb rated 220 volt 100 watt drops by 2.5% of its rated value, the percentage of the rated value by which the power would decrease is. So I will give you few minutes to try this out. Sir, I am understanding concept, but I am not able to solve KCET questions, and I have too much of backlog, like out of 37 chapters I just completed 10 chapters, Austin is saying. So Austin, plus first let me explain 37 chapters. I think you are talking about all three subjects. Okay, so you have completed 10 chapters, means 1/3 of your syllabus almost done, slightly less than 1/3. So remaining 27 chapters, what you can do, you have to identify what are all the important chapters. Okay, you don't need to do all the chapters and have unnecessary fear in your mind. For example, in physics, if you see 14 chapters from your second PU, from which 40 questions coming every year, but out of those 14 chapters, there are 5 to 6 chapters from where 30 questions are coming. Okay, so identify those 6 and 7 chapters and study all those 7 chapters completely. So 50% of the syllabus is reduced for you. And if you are studying those 7 chapters, you are going to score, already you are going to score 30 marks, fully guaranteed. Remaining 30 marks, you have to do it slowly. Okay, so there are some chapters, for example, there will be midterm exams, then pre-board exams, then there will be some monthly test in your colleges as well. So whenever the chapter which are not so important is coming, so whenever you are studying them, try to solve the PYQs from that chapter as well. And there is no other option than solving questions. Solving questions improve your retention. Solving questions improves your capacity of understanding a question, understanding a concept, and retaining the formulas as well. Okay, there are few formulas that you have to remember. For example, in moving charges and magnetism, there are a few formulas that you have to remember. There is no other option. Current electricity is a chapter where not too many formulas you have to remember. Few formulas, if you remember, that is sufficient. Okay, so that's how you can tackle your syllabus. So important chapters first, not important chapters second. And if you are starting now, if you are thinking I have too much backlog, don't think like that. Finish the important chapters first. Then you will think what are all the other chapters I can do. So that's how you make a progress. But if you keep on thinking backlog, then it will only mount. Okay, you will be under the mountain and you will not be able to overcome that fear. So that is how you should approach your study. Important chapters first, non-important chapters last. So I asked you this question and no one answered. Okay, Shinzo, Austin, I completed only 3 chapters. Shinzoid 3 chapters is not done. So even if you start today, you still have around 3-4 months to till your KCET exam. It will happen in the middle of so this is November 13th, so maybe December 13th, January 13th, February 13th, March 13th, and April 13th. So 5 months is still there. In between there will be board exam. So you have to prepare for board exam. There is no other option, because board exams also very important. 50% weightage is there for your boards. So don't ignore your boards. Many students ignore boards, especially the derivations. They practice derivations, but they do not make it perfect. So numbers are deducted there. And numerical questions also do students struggle. So if you are struggling with numerical questions, solve KCET problems. KCET problems improve your numerical question solvability. Okay, ability to solve more and more questions. That is how you can improve on your concept and board exams as well. So if voltage across a bulb rated 220 volt 100 watt drops by 2.5% of its rated value, then the percentage of the rated value by which the power would decrease. So let's solve this question. Hi Manjunath, how are you? Madhavi is also saying hi, I missed your hi. Manjunath Halada, Manjunath Chavan, the 2 Manjunaths are here. So now solve this question. How to solve it? This question came in KCET 2022, not super old. So voltage across a bulb is given, some rate is given, and they said that voltage decreases by 2.5%. Then what is the change in the power? Now what is the relationship between power and voltage? There are many of the many relationship, but what relation we will use is P equals to V square by R. P equals to V square by R. Why we are using this relation? Because R is constant for a given circuit. For this given bulb, R is constant. You can even calculate the resistance. Okay, but we don't need to calculate the resistance. What we need to do, we need to differentiate both sides. Now with respect to what? With respect to nothing, we taking differential. Okay, we can take differential. Now 1 upon R is constant. That means V square differential will be 2V dV. Okay, so this is the trick that you have to know. Now what we will do, we will divide both sides by P. Okay, we will divide both sides by P. Now what is P? P equals to V square by R. So on our left hand side we will keep it as P. On our right hand side we will write this as V square by R. Now 1 by r gets cancelled. So what we got on our right hand side? We got 2v dv by v square. One of the v's gets cancelled, so we get dp by p equals to 2 dv by v. Now why we are doing it? Why we are doing it? So if I say that some quantity is changed by say r%, some quantity x is changed by r%, what is the meaning of that? Mathematically it means dx by x into 100% is equals to r%. Okay, so this is the meaning of this. So whenever some quantity is changing, so you have solved the questions in your childhood that cost of apple increased by 10 rupees. What is the percentage change if initial price was 30 rupees per kg? Okay, so you have said that okay, the change is 10, initial price was 30, so 10 by 30 into 100%, that is the percentage change, right? So what is 10? 10 is actually change, and what is 30? 30 was initial value. So change divided by initial value, and if you multiply it with 100, you get the percentage. Okay, so basically if you multiply 100 on both sides and if you add a percentage sign, you are getting, you can convert this into percentage. So dp by p into 100% is equals to 2.5%. It is given in the question, and we are trying to sorry, not dp by p, sorry, my mistake, dv by v into 100% equals to 2.5%. Voltage drops by 2.5%. So voltage drop is given, so change in voltage percentage is given, and we are trying to find change in power percentage. Now what is the power percentage? Power percentage will be dp by p into 100%. Okay, so if you multiply 100% on both sides, you will get the change in dp by p. So that is equals to 2.5% into 2. Where this 2 is coming? This 2 is coming from here. So 5% is the change in the power. 5% is the change in the power. Very interesting question. Okay, involved a lot of mathematics question, involved some of the mathematics concept, right? Okay, now let's move on. Now we are going to discuss about cells. Okay, so what is cell? Cell is basically where we have a battery and a resistance. Okay, battery has something called EMF, electromotive force, which drives the electron in the circuit, and each cell is not free from hi Austin, yes, okay, so electric cell is basically a source of power or source of voltage which drives the current in a circuit. So basically for electric cell we have a EMF which is given by E or epsilon. In some cases we write it like this, and R is the internal resistance. Now internal resistance is always connected in series with the battery. Okay, this combination is called a cell. Cell is not only the battery. Ideal battery has zero internal resistance, but in practical cases cell do have an internal resistance, and that is why when you are using your mobile phone it becomes hot. When you are charging it or you are using it, it becomes hot because there is an internal resistance present in the battery. Okay, even if your mobile phone is switched off, if you are charging it, your phone becomes hot because some heat is being dissipated through the internal resistance. Okay, everyone try to reduce this internal resistance as much as possible. Older mobile phones used to get hotter. Nowadays we have some technology where this battery does not get hot because internal resistance values we have somewhat tried to reduce it. Now the voltage across these 2 points is called the terminal potential. Okay, because this resistance is not visible to you, this is already inside the battery. Okay, but when you are trying to measure the voltage across the battery, you get some voltage that is called terminal voltage. Now terminal voltage is not fixed, it depends on the current of the circuit. Okay, and the terminal voltage is given by original EMF of the battery minus I into internal resistance R. This is the terminal voltage that you are measuring. Okay, terminal voltage is always less than or equals to the EMF. Maximum value of terminal voltage is EMF, and minimum can be 0 as well if the entire current is being dissipated. If you short a battery, entire current will be dissipated. That means in that case V will be 0. Okay, now IR V is equals to, suppose we have an external resistance R as well, the current through this is I, so the voltage that we are measuring across this is same as voltage that we are measuring across this resistance. Okay, so voltage across this resistance is given by I into R, or IR equals to epsilon minus IR. Okay, now so I is equals to given by epsilon by R plus R. So if you know the EMF of the battery, if you know the internal resistance, based on the external resistance, you can calculate the current in the circuit. Now let's move on. One question from this same concept. The variation of terminal potential difference with current flowing through a cell is as shown. The EMF and internal resistance of the cell are. So we have done one experiment. We measured the current, we measured the voltage across the battery, and we got this graph. After doing one experiment, we got this graph, and now we are interested what is the internal resistance, what is the voltage across the battery. So if you see that in this case current is equals to 0, right? This is y-axis, that means current has to be, x-axis has to be 0, so current is 0 over here, and for this case voltage is equals to 0. Okay, so this case current is equals to 0, this case voltage is equals to 0, and we are still using our own PYQ book. If you are interested, you can scan this and get the book. So I is equals to 0, so we know that V equals to epsilon minus I R. This is the same equation we were going to use. For the first case, voltage is 3 volt, epsilon we are trying to find, current is 0, so 0 into small r. So from here we calculate epsilon equals to 3 volt. So the voltage of the battery is 3 volt. Now we have to calculate the internal resistance. So either option B or option D is correct. One of them is correct, one of them is wrong. Now we have to use the second equation. In this case, voltage V, terminal voltage is 0. Again we will be using the same equation. 0 equals to epsilon minus IR. Now epsilon equals to IR, or R equals to epsilon by I. Now what is the value of epsilon? Epsilon we have calculated 3 volt. Current from this graph we can see this is 6 ampere. So 3 by 6. So this becomes 0.5 unit should be ohm. So 3,0.5 is option D. Okay, so this is the answer for this question. Now cells in series. So far we are only discussing about one cell. Now we are discussing about multiple cells, okay, of different EMF and internal resistances. Different EMF and internal resistances are connected in series. Sir, can I get top 1000 rank, Austin? Yes, if you work sincerely, why not? You have to work on two things, your boards as well as KCET. If you are serious and if you are studying seriously, then you can definitely get less than 1000, but you cannot waste any more time. You have to follow the study plan. Study plan we have shared in our channel from time to time. Take any one of your timetable and modify according to your colleges, modify according to your exams, and study according to your preference. But do not waste too much time. If you think that I was started studying, suddenly I switched to Free Fire, or I went out with friends playing cricket for entire day in the Sunday morning, entire day, so from 5 a.m. in the morning till 12 p.m. in the day I played cricket, or I played Free Fire with my friends. So that's how you will not be able to score 1000 rank. Okay, so if you are serious, okay, I don't say that you have to study entire day. I don't say that you cannot play your games, indoor outdoor games throughout the day, but have like a restriction on yourself. So for example, my favorite game was Carom. When I was a student, I was studying, every day evening we used to play 1 hour Carom. Okay, computer and etc. was just new back in our days. Mobile phones are not there, no Free Fire was there, so we used to play Carom. So one of my 2 or 3 of our friends will come together for play, and we will play for 1 hour fixed. Okay, 1 hour, maybe maximum 1.5 hours if it is a Sunday or holiday, but not more than that. Okay, and then we will go back to our studies. So that is how you can, if you control your urges of time waste, then you can definitely score well. Okay, and you don't need to play for study for entire day as well. In between your study you can take 10 minutes break. Okay, you can relax your eyes, but stop scrolling the reels, stop playing the games continuously, because you are losing, you have to win one. So don't do that, then you will be able to score 1000 rank. That is my suggestion to all of you, not only Austin but for all of you. Okay, now let's see. So n number of cells are connected in series. What is the equivalent EMF? Equivalent EMF is easy. You add all the EMFs, you get the total EMF. You add all the resistances, you get the total resistance. So this is series. Series portion is easy. Okay, if n number of cells of same EMF is connected in series, the total EMF becomes n into epsilon, and total equivalent resistance becomes n into R. Okay, this is how you can see. Also, one more thing you have to remember, that the power dissipated in a cell, is maximum. Power is maximum when the internal resistance of a cell, or equivalent internal resistance of a cell, is equals to the external resistance. Okay, if it is only one cell, then R is equals to R. If it is there are more than one cell, you have to find the equivalent resistance of the combination and compute it with the external resistance. Then only power dissipated in the circuit will be maximum. Based on this power dissipated, also questions do come in your exam. Cells in parallel. Cells in parallel is slightly complicated. Again, 1, 1, 2, 2, 3, 3. And now if cells are connected in parallel, then their formula is, this is the easiest way to remember formula. There is one more formula given in your NCERT textbook, but that might be a little tricky to remember. This one is easy to remember: epsilon 1 by R1 plus epsilon 2 by R2 plus epsilon 3 by R3, and so on, divided by 1 by R1 plus 1 by R2 plus 1 by R3 plus so on. Okay, and in case of equivalent resistance, parallel combination, so 1 by R1 plus 1 by R2 plus 1 by R3. Now this can be written as epsilon 1 by R1, epsilon 2 by R2, epsilon 3 by R3 whole divided by this 1 by R equivalent. So this is not R equivalent, this is 1 by R equivalent. If you remember this, this is also going to be very, very handy. Now if all of the EMF of the cells are same and they are connected in parallel, then equivalent EMF is not epsilon by n, but it is actually epsilon. It will be equals to epsilon. Okay, if all the EMF and internal resistances are same, then equivalent resistance will be equals to only epsilon. So your voltage does not increase in parallel combination, but you get more stability. That is important. Okay, so you get more stability, but voltage remains same. So if you want to increase the voltage, series combination. If you want stability of your circuit, same voltage but for longer time, then you have to connect them in series. And in many cases series and parallel combinations are used together, particularly for example your mobile battery or the inverter that you are using in your home. Okay, Sainath Kote is saying yes, hello. Yes, Sainath, how are you? Welcome to the batch. Now we will be solving only questions. From now on, theory portions, whatever I was to discuss is over. Now we will be solving only questions. From now on, I will be try to complete as many questions as possible. A copper wire of length 1 meter and uniform cross-sectional area 5 into 10 to the power of minus 7 meter square carries a current of 1 ampere. Assuming that there are 8 into 10 to the power of 28 free electrons per meter cube in copper, how long will an electron take to drift from one end of the wire to the other end? So, a very interesting question, and it came in 2021. So, if you see that length of the wire is given, cross-sectional area is given, current is given, number density of electron is given, okay, and they asked how much time it will take. So completely different thing was asked. Suppose we have a copper wire, some current is being passed. Now they are saying one electron which started drift from this side, how long it will take to reach the other side. Now electron drifting means basically what we have to do, we have to calculate the drift speed. That's it. So what is the drift speed? That is our first task to find. Current is given by NEAVD. So I told you, remember this formula. So if you know the answer, please mention it, and if you have not yet subscribed, subscribe to our channel. More such lecture is going to come to our channel. So current is given by NEAVD. First we have to calculate the drift velocity. Drift velocity is given by I by NEA. And then what? Then drift velocity, we know the velocity of the electron. We know that the wire is 1 meter long. That means the time will be the length of the wire divided by the drift velocity. So that is what we are trying to find. Time is equal to L by Vd. And what is L by Vd? L by I by NEA. That means NEA into L divided by I. So this is the time that we need to calculate. So number density is given by 8 into 10 to the power of 28. Charge of an electron is known, 1.6 into 10 to the power of minus 19. Area is given 5 into 10 to the power of minus 7. Okay. And length of the wire is 1 meter. Length of the wire is given by 1 meter. And current in the circuit is given by 1 ampere. Okay, so this multiplication you have to do. So let's see. 5 into 1.6 means 8. 5 into 1.6 means 5 plus 3, that is 8. So 8 into 8 into 10 to the power. 19 minus 7. Minus 19 minus 7 is minus 26, and here we have 10 to the power of 28. So 28 minus 26, that is 10 to the power of 2. So 6400 seconds. So electron will take 6400 seconds to drift from one end to other end. That is 6.4 into 10 to the power of 3 seconds. So correct answer is option D. I will check the answer if any one of you have answered it correctly or not. Yes, Austin is saying option D. Sainath Kote is saying option D. Yes, both of you are correct. So option D is correct for this question. Okay. Now let's move on to the next question. A wire of certain material is stretched slowly by 10%. Its new resistance and specific resistance becomes respectively 1.21 times same, 1.1 times, 1.1 times, both remains the same, 1.2 times, 1.1 times. Now I will give you some second. In the meantime, I will have some water. So if you are want to solve it, please solve it. Till then I have to have some water. So let's see. Sainath is saying option A. Now this question as in this form is easy. Why I am saying this form is easy? Because the wire of certain material is stretched slowly by 10%. So you had a wire, you stretched it to 10%. So increased in length, decrease in area, but the material remains same. That means the resistivity remains the same. But because the length is increasing, the resistance will change, right? So that is a fact. But if you see all the options, only one is where resistance is increasing and resistivity is same, right? So resistivity is same. Obviously resistivity does not depend on length of the material, it only depends on the material itself and the temperature. Temperature remains same, that means resistivity will remain same. So correct option is option A. If you just understand that same resistivity will remain same, then you can answer this question. This 2.1 times does not matter. When I give these questions to student, I remove this part. Okay, I remove the resistivity part so that student have to solve it to calculate exact by how much time the resistance changes. So resistance 10% increase means 10% increase means suppose the initial length was L, the new length will be 1.1 into L. 10% means 0.1. 10% means 0.1 increase. Okay, 0.1 increase. So original length was L, that will become 1.1 L. Okay, now we know that this is known as N, right? We discussed it. So the new resistance will be N square old resistance. So new resistance will be 1.1 whole square into R. 1.1 whole square means 11 square is 121 and 1.1 square will be 1.21 into R. So this is the answer. So if you, this question is easy because you can answer it only by understanding that the resistivity remains same but resistance changes. So this is the correct answer. Okay, and if you want to calculate the exact resistance, this is how you can do it. Next question. A car has a fresh storage battery of EMF 12 volt and internal resistance of 2 into 10 to the power of minus 2 ohm. If the starter motor draws a current of 80 ampere, then the terminal voltage when the starter is on is. Again, I will give you some second to solve it. Which formula will be used, I will not say. Sainath was correct, by the way, last question. Okay, now let's see which one will be correct for this case. Car has a fresh storage battery of EMF 12 volt and internal resistance 2 into 10 to the power of minus 2 ohm. If the starter motor draws a current of 80 ampere, then the terminal voltage when the starter is on is. So the formula, I am giving you a hint, the formula that we are using is epsilon minus IR. Okay, epsilon value is given, I is given, R is given, you just need to calculate it. Okay, epsilon is given by 12 volt, current is given 80 ampere, internal resistance is given 2 into 10 to the power of minus 2. Now quickly answer it. Sainath is saying 10.4 volt, option A. Let's check. I think it will be correct. So it will be 160 into 10 to the power of minus 2, or 12 minus 1.6, or 10.4 volt. Yes, Sainath, you are absolutely correct with this question. Now next question. This is very interesting question. 10 identical cells, each of potential E and internal resistance small r are connected in series to form a closed circuit. So no external resistance is used in this case. An ideal voltmeter connected across 3 cells will read. Okay, 10 identical cells, each potential E and internal resistance are connected in series to form a closed circuit. An ideal voltmeter connected across 3 cells will read. Okay, very interesting question. So here we have like this, and there is no other external resistance. They are just connected, 10 cells are connected like this. And if you put your voltmeter across this, what will be the reading of this voltmeter? That is the question. Kishan saying, sir, can we get under 10,000 in KCET if we start studying from today? Kishan, you can get under 1,000 if you are serious and if you start studying from today. Okay, 10,000 if you start 1 month before exam also you can get. But 10,000 is not a good rank, trust me. If you want the good colleges, you have to start today and you can get 1,000 rank easily. But you have to be serious, you have to be focused. If you are doing whatever you are doing, then 10,000 what? If you think that 10,000, you will get 1 lakh. Okay, so if you start today, easily you can score less than 1,000, but you have to be focused and serious. Okay, so you have to prepare for your PU, you have to prepare for your KCET exam, but focused and serious manner. Seriousness is important. Okay, now how to calculate this voltage? Austin is saying A. Now he changes option to option 3C, and Sainath is saying 3E, option D. Okay, Austin initially was saying 13E, then he changed to C. So 3 cells only are involved. Okay, Austin. So either option B or option D could be the answer. 10 will not come over here. 10 cells are in series, yes, but we are putting the voltmeter only across 1, 2 and 3 cells out of the 10 cells. There are more cells. Okay, there are more cells over here. Total 10 cells are there. But first, how to solve it? We have to calculate the current in the circuit. Okay, only 10 cells and their internal resistances are connected. Only 10 cells and their internal resistances are connected. So what is the total EMF? Total EMF is basically 10E. Total resistance is 10R. So what is the current? Current is given by total EMF divided by total resistance, that is 10E by 10R. Okay, so what is the current? Current is given by E by R. Now voltmeter do not know what is a cell. Voltmeter only know what is a resistance. Okay, that is the beauty of a voltmeter. Voltmeter does not know what is a cell. Voltmeter knows, okay, if there is a resistance, there is a current, then what is the total voltage across this resistance. That is what voltmeter knows. So when you are measuring using a voltmeter, voltmeter will measure the current times the total resistance. Current times the total resistance the voltmeter will measure. Voltmeter will not identify any voltage is there or not. Okay, so current in the circuit is given by E by R, and resistance we know, which is given by 3R. Okay, 3 cells. 3 cells means R plus R plus R. So R cancels and we get voltage equals to 3E. So voltage will be 3E. Not option A, not option C, not option B, but option D. So Sainath is correct in this case. Next question. E vector is the electric field inside a conductor whose material has conductivity sigma and resistivity rho. The current density inside the conductor is J vector. The correct form of Ohm's law is, so I discussed this while teaching the theory. So we have a current carrying conductor and they are asking about what is the correct form of Ohm's law. So Ohm's law, there are two forms. One is V is equal to IR, another one is E is equal to sigma E equals to J. Okay, but if you see that none of the option is given over here. So in vector form, this is the correct form, but none of the option is given in this particular case. So we have to modify. What we will be doing, we will check E equals to J vector divided by sigma. Okay, so Austin is saying option C. Yes, Austin. So you have listened to my lecture, so you should be able to answer it. E equals to rho J. Okay, this is actually an intermediate step while deriving this formula. Okay, this is an intermediate step. From here we are coming to this formula. So this is the correct answer, option C. Now let's see question number 9. This is a little difficult question. The equivalent resistance between the points A and B is. So this is called an infinite circuit, infinite combination of resistances. Okay, why so? Because 2 ohm, 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 and same pattern continues till end. Okay, so that's why it is called an infinite resistance. What is the resistance between the wire? Okay, but they have not given any options such as infinity. That means even if it is an infinite circuit, it does have a finite resistance. Okay, infinity is not given an option. That means it does have a finite option. Yes, Sainath, your answer was correct. Okay, now let's see. So here there is a trick. What is the trick to solve such questions? The trick to solve such question is that we cut the circuit here and here. Take this portion separate. Also we say that when we put a measuring device here, the total circuit, when the circuit is infinite, the total resistance of the circuit is R. Okay, this is the equivalent circuit, and we are trying to find the value of R in this particular case. Okay, but before doing that, what we will be doing, we will cut this portion and keep it separate. This initial portion of the circuit, we will keep that separate. Okay, now the equivalent resistance is no longer R. Okay, we only have this much. Now we will draw this portion again. So this portion again we will be drawing. Okay, now this is an infinite circuit, so I can draw one more and I can say okay, dot 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 dot, whatever was there. Now if you see this circuit and this circuit, what is the difference? I have taken the first portion out. Okay, so we are only seeing this portion here. Okay, so this is say point C and this is point D. So now in my diagram, this is point C, this is D. But if you see these two circuits, is there any difference between this one and this one? So this one is also an infinite circuit, this one is also an infinite circuit. This one and this one looks exactly the same, right? So exactly the same means if the equivalent resistance of this circuit is R, then equivalent resistance of this circuit should also be R. This is how you should solve an infinite circuit. So in infinite circuit, this resistance, whenever you cut the portion, first portion you take separate, then you take the repeated portion and say that entire circuit will have the same resistance R. and this was our point C, this was our point D, and this resistance is R, so we will add that exactly between C and D. Okay, now what is the equivalent resistance of this portion? This portion is R, we already know, so this is also R. Okay, now we will try to find the equivalent resistance and say this is the value equals to R. This is 2, this is 2, this is 2. These two are in parallel, so the equivalent resistance between them is 2R divided by 2 plus R. So this is the equivalent resistance of these two resistors. 2 and 2 are in series, so plus 2 plus 2. So this is the total resistance, and that should be equals to this value R. So you might be confused, sir, you started with R, this is also R, this is also R. Yes, this is the trick, this is the technique of solving such questions, where you take a repeated portion, stretch it to infinite and say the total resistance of the first circuit is R, then total resistance of the second circuit will also be R, and then we take back the same circuit, put it in the parallel and say whatever was the original resistance, that is R. Because it's infinite circuit, this small change does not matter. Okay, now we have to solve. We will get a quadratic equation and we have to solve it. 2R by 2 plus R plus 4 equals to R. Okay, now what is the quadratic equation? 2R plus 8 plus 4R equals to R into 2 plus R. So first stage we did this, okay, 2R plus 4 into 2 plus R, that is this one, and then 2 plus R will be in the division, that 2 plus R we have taken in the other side. Okay, so we got 8 plus 6R equals to 2R plus R square. Now we take this on the other side and we get the equivalent, we get the actual quadratic equation. What is that? R square plus 2R minus 6R minus 8 equals to 0, or R minus 4R minus 8 equals to 0. This is the quadratic equation. Now there is no direct roots of this equation. You have to use quadratic root formula to calculate the value of R. So R will be equals to minus B, that is minus of minus 4 plus 4 plus or minus square root of B square minus 4AC. B square is 4, that is 16, minus 4AC, 4 into 1 into minus 8, that will be plus 32, right, divided by 2A, divided by 2A, 2 into A is 1 over here, right. So 4 plus or minus square root of 48 by 2, okay, or 4 plus or minus 48 means 3 into 16, that is 4 root 3 by 2. Okay, now I am running slightly out of space. So this will be given by R equals to 2 plus or minus 2 root 3. Okay, now resistance cannot be negative, so only positive value we will take. If you take this negative value, then the resistance will be negative, which is not possible. That's why we are only taking the positive value. So 2 plus 2 into 1.7, that is 2 plus 1.73, okay, 2 plus 3.46 or 5.46 ohm. 5.46 almost equals to 5.5 ohm. Okay, so correct answer in this case is A. Now this is a long question. If similar question comes in your exam, then answer will be slightly longer, but there is a shortcut way to remember that. All the resistances will be equal. So what is the equivalent resistance? The shortcut way is that the equivalent resistance will be all the resistances. Okay, if similar pattern comes, okay, only for similar pattern. If the pattern changes, the formula changes. Okay, R plus R root 3, or R gets common, 1 plus root 3. But this is only for this pattern. So instead of same question, if they give you 3 3 3 3 3 3 3 or 4 4 4 4 4, then this formula can be used. But if the pattern is something different, then this formula cannot be used. You have to find it out in the exam hall itself. Okay, now next question. Fatima is saying, sir, physics is hard, can't solve the question, please help in that and make physics easy, and short tricks please, sir. So Fatima, as I mentioned, short trick is this. If you know this is the pattern, and in that case the resistance formula is simply this one line, use this formula, put the values and you get the answer. Okay, if the pattern is different, then I cannot help you, you have to do it yourself. Okay, we will be solving some more questions in future, so do check that out. But remember that 90%, 80% physics questions are not that difficult. Just put the formula, put the values, get the result. Okay, and in many cases in KCET, if you read the questions properly, you will be able to answer. A wire of resistance capital R is connected across a cell of EMF epsilon and internal resistance small r. The current through the circuit is I. In time t, the work done by the battery to establish the current. Now this is an easy question. So they have given you a battery, they have given you a small resistance R, okay, and we have an external resistance capital R as well. The current in the circuit is capital I. They said after time t, what is the work done by the battery? Okay, this is an easy question. Austin in between is asking, sir, do Sainath is saying, sir, do Diksha have offline crash course in month of March? Yes, Sainath, there will be offline crash course in the after your board exams are over, but in Diksha campuses. That will be, once it is available, it will be obviously being revealed in our channel. Diksha do have offline crash courses, in paid crash courses in our Diksha campuses as well. There are, if you are a Diksha student, then there is already a free crash course. If you are not a Diksha student, there is a paid crash course available across not all Diksha campuses. There are few selected 5 or 6 campuses. There we do have offline crash course. Okay. Austin, which one you are asking the previous question? I explained 2-3 times. So the main thing you have to remember is that this is an infinite circuit. In infinite circuit, first point is to identify the point of symmetry. So if you cut it, suppose if I cut this circuit, from here, okay, then this does not resemble with this circuit. There is this 1-2 ohm extra. Okay, so you have to identify which portion is similar. Okay, so here is a gap here. So if we cut it from here, there will be a gap here as well. Okay, so first point is to identify the symmetric part. Okay, and now why we are not cutting it from here? We are keeping the minimum possible number of resistances. That is easier. If you cut the resistance from here also, you will get the same result. No matter what, if you try to solve that, you will get the same result. Problem will be much harder to solve. Okay, this is the shortest way to solve it. That's why we are cutting it from this point. And we are seeing that the remaining portion is also same as the original circuit. Okay, because it's an infinite circuit, the resistance of this portion is same as the original circuit. Okay, so if the original circuit has resistance R, then our new portion should also have resistance R, because it's an infinite circuit. Okay, that is the logic, that is the understanding you need to have to solve any infinite circuit related question. Okay, so for example, if you get one more resistance is added along the diagonal, okay, then again you can cut it from this, but this shortcut formula will not be applicable. So what I am saying, that if same question is asked and you have a resistance over here, this is also a circuit, same 2 ohm resistance is there, everything is still 2, but we have one extra resistance like this. So here also we will cut it along this, so that the circuit symmetry remains the same, but here we will have one extra 2 ohm resistance to tackle at the end. Okay, that's it. So resistance will be increased in that case, but pattern will be same. Now this you can take as a homework and try to solve it yourself. If you try to solve it yourself, you will understand what I am trying to say. So take this portion, the total resistance of the entire infinite circuit is R. If you remove this portion, again the entire circuit still will be R. Now what we will do, we will take this portion and the removed portion, and we will add this as R in parallel, and then we will solve it. Okay, so this is the trick to solve, right? I hope this is clear. Now take this as your homework. Same circuit, these diagonals, we now have 2 ohm resistance. Okay, I will be solving in Saturday's class. Saturday's class, attend. I will try to solve this question. Okay. Now question number 11, in an atom, electron revolve around the nucleus along the path of radius 0.72 angstrom, making 9.4 into 10 to the power of 18 revolutions per second. The equivalent current, given that the charge of an electron is given. Okay. Okay, now solve it. Yes, last question I missed it. So last question was current is given, resistance is given, okay, time is given, what is the voltage, what is the work done? Work done is the power dissipated in the resistance. Work done is power dissipated in the resistance, which is given by I square R into T. I square R into T is the power dissipated in the circuit. So correct answer is I square R into T. Okay, this is the actual answer, not this one. Okay, this one is not the answer for this question. Epsilon IT, even though epsilon is the EMF of the circuit, but to establish the current through an external resistance, internal resistance wastage will always be there. Okay, so to establish this current, the battery is actually doing this much work. This is the actual useful work. Remaining work is actually waste. So that work we will not count. We will only count the useful work. I square RT, VIT, okay, whatever is there, but V is not given, I is given. So I square RT is the actual work that is being done by the battery. Okay, next question. In an atom, electron revolve around the nucleus along a path of radius 0.72 angstrom. So electron is revolving around this path. Okay, making 9.4 into 10 to the power of 18 revolutions per second. The equivalent current is given by. So equivalent current, what is current? Current is charge divided by time. Okay, so we need to calculate the charge which is passed at particular point. So if when the electron is revolving one time, the charge is E. If the electron is revolving 2 times, charge will be 2t. If the electron is revolving 3 times, charge will be 3t. But here, electron is revolving n number of times, then the total charge will be n into E by t. So this radius is actually given to distract you. This radius is not required here. Only thing is the number of revolution the electron is making per second. So time is 1 second, number of revolution is 9.4 into 10 to the power of 18, charge of electron is 1.6 into 10 to the power of minus 19, time is 1 second because this is per second, revolutions per second. That means 9.4 into 1.6 into 10 to the power of minus 1. Okay, now you can calculate it. It will be somewhat around 10 into 16, less than 16, it will be around 15 into 10 to the power of minus 1. You can check that out. So how I have calculated, because in KCET you are not allowed to use calculator. Suppose the 9.4 is equals to 10, approximately 10, then 10 into 1.6 will be 16, right? But 9.4 is not 16. That means 9.4 is not 10. So that means our result should be slightly less than 16 and it will be closer to 15. 14, 15, both of are fine. So the current will be 1.5 ampere. So 1.5 ampere is the correct answer. Not 1.8 but 1.5. We will take 1.5. We will not take 1.4. We will not take 1.2. We will only take 1.5. Okay. Now question number 12. A charged particle is moving in an electric field of 3 into 10 to the power of minus 10 volt per meter with mobility 2.5 into 10 to the power of 6 meter square per volt second. Its drift velocity is. Sainath was saying 1.5. Yes, Sainath, correct answer. 1.5. Also Austin, correct answer. Now answer this question. Electric field is given. Mobility is given. They asked you what is drift velocity. Okay, formula again I told you while doing the lecture that mobility is drift velocity per unit electric field. That means drift velocity is basically mobility into electric field. So you just need to multiply these two quantities to calculate. So you can see Fatima and all those who are thinking KCET is difficult. If you remember few more formulas, if you start improving on your formulas improvement, then KCET is actually not hard. Okay, and this question came very recently, 2022. So this type of questions are common, but you need to understand what formulas you have to utilize. For that, practice PYQs, make a formula sheet. I will try to give you one formula sheet in future. But that is work in progress. So formula sheet, create a formula sheet on your own and then understand what are the formulas that is coming in KCET. For that, that's why you have to solve PYQs. And then once you are aware, okay, these are the formulas that is coming again and again, make the formulas, and then problem is simple, life is simple. Mu is given by 2.5 into 10 to the power of minus 6 into 10 to the power of plus 6 into electric field is 3 into 10 to the power of minus 10. Okay, so 3 into 25 is 75, so 7.5 into 10 to the power of minus 4. 7.5 into 10 to the power of minus 4 meter per second. The correct answer is option B. Yes, Austin and Sainath both are correct. Question number 13. The electric current flowing through a given conductor varies with time as shown in the graph below. The number of electrons which flow through a given cross section of the conductor in the time interval 0 less than t less than 20 seconds. So we have to find the total amount of charge, which is a total amount of electrons that is being passed through the conductor. How to do that? For that we know that current is basically given by Q into T. So total charge is given by I into T. So if we plot a graph of current versus time, if we plot a graph of current versus time, then area under the graph is basically this I into T. So x into y. Okay. For small integral dq dt, take integration, then also it is the same thing. Basically, if you take the area under the graph, then if any quantity can be represented, say x equals to yz, and if you plot y versus z, okay, and if you know the graph, then area under the graph will give you this quantity x. Okay, this is the geometry. This is coming from geometry. We have used that in VT graph as well. Okay, velocity time graph, V into T, right? Area under the graph gives displacement. Similarly, Q is equal to IT. Now, they have not asked you to find the total charge. They asked you to find the total number of electrons. So, from quantization principle, we know that N into E equals to IT. Okay, so En equals to IT by E. Okay, and so once we calculate the total charge, we have to divide it by the charge of an electron to calculate it. Now, first step is to calculate the area under the graph starting from 0 till 20. So, this area we have to calculate. Okay, this area we have to calculate. Okay, so how to calculate the area under the graph? So this can be converted into two portions. One is this trapezium, and one is this rectangle. So what is the area of a trapezium? Area of a trapezium is given by, so if you add these two areas, we will get the total area. So area of a trapezium is given by half into the addition of the parallel sides, that is 100. Now also axes are not given, so this is 0, this is 200, so middle point will be 100, and this is 200, this is 400, so midpoint will be 300. Okay, these are not given, so you have to figure that out as well. So area of a trapezium is addition of the parallel sides, so 100 plus 300, so 100 plus 300 times the distance between the parallel sides. So distance between the parallel sides is 10 minus 0, that is 10. So 400 into 5, that is 2000. This is the first portion. Now this is given in milliampere, so you have to multiply with 10 to the power of minus 3, so it will be actually 2. This is effectively giving you 2 coulomb of charge. This much area gives you 2 coulomb of charge. What about the next portion? Next portion is a rectangle, so it's easy. Length into breadth. Length is maximum value, that is 300. Breadth is this one, 20 minus 10, so breadth is 10. So area for that is 300 into 10, that is 3000. Again 10 to the power of minus 3 is there because of this milliampere, so it will be 2 coulomb here, 3 coulomb here. So total charge, that is this, is given by 2 plus 3, that is 5 coulomb, divided by 1.6 into 10 to the power of minus 19. So 5 by 1.6 into 10 to the power of plus 19. So it will be around 3 into 10 to the power of minus plus 19. Now how I arrived this as 3? 5 by 2 is 2.5. 5 by 2 is 2.5. Here we have less than 2. So less than 2 means it will be closer to 3. Okay. So this is how you develop your approximation skills. Developing approximation skills is also very, very important. Stop using your calculator for every now and then and every small calculations. Okay. So correct answer is 3.125 into 10 to the power of 19. Okay. So option A, Sainath answered. Sir, please some questions from 2025. 2025, Sainath, I have already done in the past. Today we do not have 2025 questions. We have up to 2024. Okay, so this is a question from 2024. 2025 questions I believe was little easy. Okay, there are direct graph based question and few simple calculation based question. Conceptual questions was not there too many, not too many questions are there in 2025, so that's why I choose some questions from 2024. The IV graph for conductor at two different temperatures, 100 degrees Celsius and 400 degrees Celsius, is as shown in the figure. The temperature coefficient of resistance of the conductor is about in per degree Celsius. So here we have to calculate the temperature coefficient, alpha. Okay, how to calculate alpha? To calculate alpha is basically difference in temperature RT minus R naught divided by R naught into T. This is the formula to calculate temperature coefficient. Okay, now what is RT? RT is the resistance at higher temperature, 100 is resistance at the smaller temperature. So first we have to figure out what is the temperature at higher case, which one is higher, which one is lower. So I versus V graph is given. Now we know that I into R equals to V, or resistance is equals to V by I, right? Or resistance is equals to delta V by delta I. Okay, so resistance is equals to delta V by delta I, but in this graph if you see that I versus V graph is given, that means it is opposite to that. So 1 upon R is equals to delta I by delta V. So why we are interested in I versus V graph? Because the slope we can calculate using this angle. Slope we can calculate using this angle. So 1 upon R, 1 is basically tan 30. Tan 30 is 1 by root 3. So R1 is root 3, that is 1.7, and 1 by R2 is equals to tan 45, that is 1. So R2 is equals to 1. So R1 and R2 both we have calculated. Now from this calculation, higher the resistance, higher the temperature. So this represents the resistance at 400. This represents the temperature of 100. Okay, now put those values over here. So it is 1.7 minus 1 divided by 1 into 400 minus 100. This is the easiest formula to calculate alpha. So it will be 1.7 divided by 300, which will be approximately 0.5 into 10 to the power of minus 2. Okay, so 0.5 into 10 to the power of minus 2, slightly more than 0.5. I have assumed it's 1.5, right? So 5, say 5. So it will be 5.5 into 10 to the power of minus 3, and close value in the given option is B, 6 into 10 to the power of minus 3. Okay, so they have taken it 1.8, I have taken 1.7. That's why there is a difference, but it will be very, very close. Okay, now next question, last question of the day for everyone. An electric bulb of 60 watt 120 volt is to be connected to 220 volt source. What resistance should be connected in series with the bulb so that the bulb glows properly? Okay, an electric bulb of 60 watt 120 volt is to be connected to a 220 volt source. What resistance should be connected in series with the bulb so that the bulb glows properly? The power rating of the bulb is 60 watt 120 volt. So we have a bulb, okay, and the power source that we have connected is 220 volt. We have to connect an extra resistance so that the bulb glows properly. Now if the bulb glows properly, then the voltage drop across the bulb should be equals to 120 volt. This is the one and only condition for the bulb to work properly. But the source that we have applied is 220 volt. So what will happen to the remaining 100 volt? The remaining 100 volt should go across the resistance. the remaining 100 volts should go across the resistance. Now if you know what is the current that is being passed in the circuit, we can calculate the value of the resistance. Now how to calculate the resistance? The bulb is glowing properly, that means it is utilizing 60 watt power, voltage is 120 volt, that means power equals to Vodafone Idea. Okay, power is 60, voltage is 120, then the current that is passing in the circuit is given by 60 by 120, that is 0.5 ampere. So 0.5 ampere is the current which is being passed in the circuit. So current we have calculated. Now what we need is to calculate the resistance. So voltage we know this is 100, current is I. So from Ohm's law, voltage must be equals to IR, so IR must be equals to 100, I is 0.5 into R is 100, so R must be 100 divided by 0.5, that is 200. So 200 volt, 200 ohm is the correct answer. So option C is correct answer for this question. Yes, Austin, Sainath, Austin, both of you are correct. So correct answer is 200 ohm. So KCET questions are not difficult. If you see, KCET questions are actually easy. Even 2025 also, there are a lot of direct questions being asked. I will try to include some 2025 questions in our next session. Next session will be very, very essential. KCL and KVL along with some more PYQs I will be solving. And also I will be discussing how to tackle circuit theory. Circuit theory, you know, many students fear that, sir, I don't know how to solve circuit theory, I don't know how to solve unbalanced Wheatstone bridge, I don't know how to solve if the circuit gets complicated, how to apply KCL, KVL, I apply it correctly, but at the end I don't get the correct answer, I was losing marks. So that's why I have decided that KCL, KVL for PU, for your KCET, everything will be covered in the next lecture. Okay, so I hope many of you will join me in that lecture. Today's lecture is over here, and if you have any more doubts, any comments, please mention that in the comment section below. Bye everyone. Thank you for watching, and also don't forget to subscribe to our channel, because subscription is important, and also we are nearing 1 lakh, and there will be some surprise for you if we reach 1 lakh very soon. Okay, till then, bye.